Hello, good morning children. So let us continue our lesson on polynomials part 3. So far we have seen the different concepts in polynomials, that is values of a polynomial, zeros of a polynomial, geometrical representation of polynomials, and the significance of zeros from the graph of a polynomial. We have seen that from the graph of a polynomial we can get the zeros of the polynomial by taking the x coordinate of the point of intersection or points of intersection of the graph. Okay, now further we proceed on relationship between zeros and coefficients. So the different terminology, zeros, coefficients, you know it. Now we will examine different types of polynomials based on this. First we consider linear polynomial. The standard form is ax plus b a not equal to 0. Now here the zero of this polynomial is given by x is equal to negative b by a, that is negative of constant term of the polynomial divided by coefficient of x, and there is only one zero for a linear polynomial, so there is no other relation, only the value of 0 is given to me. So in a polynomial, if the variable is x, the different values of the constants a and b determines different polynomials. So it's 0. Whatever may be the values of real values of a and b, the only 0 of this polynomial is given by negative of constant term of the polynomial divided by coefficient of x. Okay, now we move on to quadratic polynomial, and you know the standard form or general form of this polynomial is ax square plus bx plus c a not equal to 0. It's not compulsory that always these three terms should be present. Compulsorily ax square must be present. That's why a not equal to 0. Now, as you know, the number of zeros of a quadratic polynomial is equal to 2. In general, if you are given a polynomial, the maximum number of zeros of any polynomial will be equal to the degree of that polynomial. So, first degree polynomial 1 0, quadratic or second degree polynomial can have maximum 2 if there is, and for a cubic polynomial there can be 3 zeros likewise. So let alpha and beta be the two zeros of this polynomial ax square plus bx plus c. So there are two zeros. We denote the zeros by alpha and beta. These are two Greek alphabets, so to represent the zeros. Now we have the two zeros, x is equal to alpha and x is equal to beta are the zeros of this polynomial px given by ax square plus bx plus c. Now in class 9 you have studied, if x is equal to a is a zero of a polynomial p of x, then x minus a is a factor. So likewise, since x is equal to alpha is a 0, then x minus alpha is a factor, and x is equal to beta is another 0, so that x minus beta is also a factor. So we get x minus alpha and x minus beta are the two factors of p of x. Now you see, we are going to write the form of this polynomial p of x from its factors. In the number system we have studied, suppose you take the number 10. When you prime factors, you get factors 2 and 5. So 2 into 5 becomes the number 10. So 2 into 5 is the factorized form. So once you know the factors of a number, you can get the number by multiplying its different factors. Likewise, here x minus alpha and x minus beta are the two factors of p of x. And p of x is a second degree polynomial ax square plus bx plus c. So this x minus alpha, x minus beta, when you multiply it will become a second degree polynomial, and the remaining factor may be a constant only. There is no other linear factor for p of x. Since when you multiply x minus alpha and x minus beta, you get a second degree already. Now the question remains, that maximum there can be a constant if at all there is, otherwise it will be 1. So we can write this p of x from its factors by multiplying x minus alpha, x minus beta and another constant, say k. So px is of the form k into x minus alpha into x minus beta. Now multiplying these two brackets, you get x square minus alpha x minus beta x plus alpha into beta. So we can rewrite it as k into x square minus of alpha plus beta into x plus alpha into beta. Minus alpha into minus beta is positive alpha beta. It's multiplication of these two brackets. Now px was given to be ax square plus bx plus c. That was the original polynomial what we have taken. So this polynomial now is of the form ax square plus bx plus c, that is equal to k into x square minus alpha plus beta into x plus alpha beta. So when you multiply, you get kx square minus k into alpha plus beta into x plus k into alpha beta. Now these two polynomials are equal. When two polynomials are equal, the coefficient of the corresponding terms, like terms, should be equal. So on the left side, coefficient of x square is a, and on the right side the like term is kx square and its coefficient is k. So these two terms should be equal, then only these two polynomials will be equal. So taking that concept, we get a is equal to k, coefficient of x square on both sides, they should be equal. So k is equal to a. Then equating the coefficient of x on the left side and the right side. Left side there is b and the right side there is minus k into alpha plus beta. So these two should be equal. So we get minus k into alpha plus beta is equal to b. And thirdly, k into alpha beta should be equal to the constant term c. So k alpha beta is equal to c. So we get these three by equating the coefficient of like terms. Now a is equal to k. Then from the second, alpha plus beta is equal to b by negative k or minus b by k. But k was a. So putting that value, you get alpha plus beta is equal to minus b by a. And from this one, k into alpha beta is c means alpha into beta is equal to c by k. But k was a. So putting that value, you get alpha into beta is equal to c by a. So you see, we got these two relations. Alpha and beta were the two zeros of this polynomial ax square plus bx plus c. So that alpha plus beta is equal to negative b by a and alpha into beta is c by a. See, these two relations are giving some equation form or some peculiarity of these two zeros of the polynomial. So these two zeros are depending on the coefficients only, not the variable. Nowhere there is x. It depends on a, b and c, where a, b and c are the coefficients of this polynomial, of different terms of this polynomial. So we can summarize this concept that for the quadratic polynomial ax square plus bx plus c not equal to 0, sum of the zeros, that is alpha plus beta, is equal to negative b by a, that is negative of coefficient of x by coefficient of x square. And product of the zeros, when you multiply these two zeros, alpha into beta, will be always equal to c by a, constant term divided by coefficient of x square. So these two relations are very important. Whenever you are given a polynomial and given two zeros, always these two zeros alpha and beta will be satisfying these two conditions. That is, when the two zeros are added, you will get minus of b by a, and when you take the product of the two zeros, you get it's equal to c by a for quadratic polynomial. Okay. Now we further move on to cubic polynomial ax cube plus bx square plus cx plus d a not equal to 0. And here the degree is 3. So how many zeros can there be maximum? It will be surely 3 zeros. So we can go for that, let there be 3 zeros. In all the cases, there may not be 3 different zeros. There are cases where there is no 0, 1 0, 2 zeros and 3 zeros. Okay, let us assume that there are 3 different zeros. Let alpha, beta and gamma, new Greek alphabet you have joined. alpha, beta and gamma be the three zeros of this cubic polynomial. Now proceed in the same way. X is equal to alpha, x is equal to beta, x is equal to gamma are zeros of this polynomial, so that x minus alpha, x minus beta and x minus gamma are factors of it, equating this in the same way what you have followed in the second degree polynomial or quadratic polynomial. Finally, you can get these three relations. For quadratic polynomial, there were two relations, alpha plus beta and alpha beta. Here we have three relations because there are three zeros. Sum of the three zeros, alpha plus beta plus gamma, is given by negative b by a. So it's in the same way. Negative of coefficient of x square by coefficient of x cube. Then sum of the products of two zeros at a time, that is alpha into beta plus beta into gamma plus alpha into gamma, and that is given by c divided by a, that is coefficient of x by coefficient of x cube. And lastly, alpha into beta into gamma, product of the three zeros, is given by negative of d by a, negative of constant term divided by coefficient of x cube. So it's in the serial way it is going. So alpha plus beta plus gamma, sum of the three zeros is equal to minus b by a. Alpha beta plus beta gamma plus alpha gamma is given by c by a. And product of the three zeros, alpha into beta into gamma, is given by negative d by a. So see that alternatively they are negative, positive, negative. So these three are the relations when you consider the three zeros, alpha, beta, gamma of a cubic polynomial. So we can summarize the three cases for linear polynomial, quadratic polynomial and cubic polynomial. There are certain relations between the zeros and coefficients of the different terms of the polynomial. And for the linear polynomial ax plus b, there is only one relation, that is the zero itself is given by negative of b by a. For the quadratic polynomial ax square plus bx plus c, sum of the zeros alpha plus beta is given by negative b by a, and product of the zeros alpha beta is c by a. And for the third degree polynomial ax cube plus bx square plus cx plus d, alpha plus beta plus gamma is given by negative b by a. Alpha beta plus beta gamma plus alpha gamma is c by a, and alpha into beta into gamma is given by negative d by a. So remember these three relations. Now let us apply this concept, the concept that you have seen so far in solving certain questions. For example, verify the relationship between zeros and coefficients of the polynomial x square minus 2x minus 8. What's the degree of this polynomial? Surely it is second degree quadratic polynomial. So we go for the polynomial x square, comparing it with the ax square plus bx plus c. So there can be two zeros. So we have to find the zeros. We don't know about the zeros. So first we go for finding the zeros of it. And for finding the zeros of it, we are going to factorize this polynomial. You have seen in the lower classes, and this year also you have done it. So factorize this polynomial x square minus 2x minus 8. So here you see, surely we can use the method of splitting the middle term to factorize x square minus 2x minus 8. So x square minus 2x minus 8 can be written as x minus 4 into x plus 2. Here this minus 4 and 2 we have assumed, you have guessed it by the values of this one. See, by splitting the middle term, that is sum of two numbers should be the coefficient of x, the middle term coefficient, that is negative 2. So negative 2 is the sum of two numbers, and this constant term minus 8 will be the product of the same two numbers. So from this product negative 8 you can get in different ways, 1 into 8, 2 into 4, 4 into 2, 8 into 1 likewise. And since the product is negative, then one of the numbers is negative. So we get negative 8 can be written as negative 4 into 2, positive 2. And the sum of negative 4 and positive 2 is positive. Negative 2, negative 2. Pardon, it is minus 2 is equal to negative 4 plus 2. Okay, so that we get the two numbers negative 4 and positive 2. So we can write this is of the form the identity x square minus x plus alpha into x plus beta is equal to x square minus alpha plus beta into alpha beta plus alpha beta is the identity which we use, and here alpha is minus 4 and beta is positive 2. So the factors are x minus alpha into x minus beta, or x minus 4 into x plus 2. So the factors of x square minus 2x minus 8 are x minus 4 and x plus 2. So the zeros are given by, since it is a product, now we have written this polynomial as the product of these two factors. Now to find the zeros, you have to equate this polynomial to 0. The polynomial should be equal to 0. That means x square minus 2x minus 8 is equal to 0. That is x minus 4 into x plus 2 is equal to 0. So when the product is 0, each one can be equated to 0. Either x minus 4 is equal to 0 or x plus 2 is equal to 0. And from these two, we get x is equal to 4, positive 4, and x is equal to negative 2 are the two zeros of this polynomial. Now we got 2 zeros. And in the process, we are denoting the two zeros of a quadratic polynomial as alpha and beta. So one of these values we can call it as alpha. So let alpha is the first value, say 4, and beta is the second zero, that is negative 2. Now we need to verify the relation. There are two relations. One is sum of the zeros alpha plus beta, and second one is product of the zeros alpha and beta. So first we go for finding alpha plus beta. So here alpha is 4, beta is equal to negative 2. So alpha plus beta is equal to 4 plus negative 2, that is 2. And by the relation alpha plus beta is negative b by a. This is the relation which we have to verify. So go for finding each one separately. We have to verify it. So negative b by a, find out. Here the polynomial is x square minus 2x minus 8. So that is equated to ax square plus bx plus c. So what is a? A is equal to coefficient of x square 1. B is equal to coefficient of x, that is negative 2. And c is the constant term, that is negative 8. So minus b by a is minus of minus 2 divided by a is 1 by 1, that is positive 2. So these two are equal. So we can get that alpha plus beta is equal to negative b by a, that is verified. Now go for the second one. Similarly, alpha into beta. Alpha is 4, beta is negative 2. So 4 into negative 2 is negative 8. And find out c by a. C by a, constant term is negative 8 by a is 1. So it is negative 8 by 1, which is negative 8. These two are equal. So we get alpha beta is equal to c by a. So these two relations are verified. Okay. So remember the method. Now, one more question we'll go for. Find a quadratic polynomial with 1 by 4 and 2 by 3 respectively as the sum and product of the two zeros. That is, we have to get the polynomial where the sum of the two zeros, say alpha and beta, alpha plus beta is 1 by 4, and when you multiply the two zeros, you get alpha into beta is equal to 2 by 3. So you have to form a polynomial with these relations. Okay, so let us see how to proceed. As usual, we can denote. Let us call that alpha and beta be the two zeros of this polynomial, ax square plus bx plus c. We are going to write that polynomial. So once you calculate the values of a, b and c, we can write the polynomial. So now the question reduces to find the values of a, b and c, where ax square plus bx plus c is the polynomial. Now let alpha and beta be the two zeros. So as soon as you are given the values of two zeros, or you are knowing the zeros of a polynomial, there are all of a sudden you should get the relation that sum of the zeros and product of this, there are two relations. So go for that. One is alpha plus beta. Sum of the zeros is given by negative b by a. But we don't know the values of a and b. So it is given that sum of the two zeros is 1 by 4. That is given in the question. This 1 by 4 was the sum of the two zeros. So alpha plus beta is equal to 1 by 4. And product of the zeros were given to be 2 by 3. So alpha into beta is equal to 2 by 3. So we have two equations. Alpha plus beta is equal to 1 by 4 and alpha beta is equal to 2 by 3. But we know that since this is the polynomial, alpha plus beta, sum of the zeros is given by negative b by a. And from that we get negative b by a is equal to 1 by 4. And alpha beta was given to be c by a. So C by A is equal to 2 by 3. So the question now reduces to solving these two equations. Negative B by A is equal to 1 by 4 and C by A is equal to 2 by 3. See here, these are two equations. And on the left side, the two equations are having denominators same, A and A. But here on the right side, in one place it is 4 and in the other second one, the denominator is 3. When these two values are equal, then only we can compare these values of A. So now the question reduces to find or making the denominator of these two values 1 by 4 and 2 by 3 equal. You have studied in the lower class how to make 4 and 3 equal. We are going for the LCM of 4 and 3, that is 12. So make the denominator of each equation as 12 by multiplying with the same constant. So making the two rational numbers like, we get minus b by a is equal to 1 by 4, that is equal to 3 by 12. We are going to make the denominator 12 by multiplying both sides, by both the numerator and denominator by 3. So 3 by 12, and c by a second one is 2 by 3, which is equal to 8 by 12. Now the denominators are same. So 12, 12. So the value of a in this is 12. Similarly, minus b is equal to positive 3, b is equal to negative 3. Similarly, c is equal to 8. So we have the comparative values. We get a is equal to 12, b is equal to negative 3, and c is equal to 8. So directly substitute the values of a, b, and c in this polynomial. So it is 12x square minus 3x plus 8. This is the required polynomial. So this is how you find the polynomial when sum of the zeros and product of the zeros are given. So similarly, in the case of third degree polynomial also, you can proceed by the 2. So you go for the assignment. In your NCERT textbook exercise 2.2, the questions based on these concepts are there. So try to do it, and for any doubt you can contact me. Okay. Now another question. For a cubic polynomial, how to form the cubic polynomial when the three relations you have studied, the three relations alpha plus beta plus gamma, alpha beta plus beta gamma plus alpha gamma, and the product of the three zeros alpha beta gamma. So write the cubic polynomial with the sum of zeros, sum of the products of two zeros at a time, and the product of the zeros are respectively 3, 1 and negative 1 by 3. So you have to form a cubic polynomial where the sum of the zeros is given to be 3, and sum of the product of two zeros at a time is 1, and the product of the three zeros is negative 1 by 3. So as usual, we can go for the three zeros as alpha, beta, gamma of ax cube plus bx square plus ax plus d. Now the question reduces to finding a, b, c, d. As in the previous case, you proceed. So we have the relations alpha plus beta plus gamma is negative b by a, alpha beta plus beta gamma plus alpha gamma is c by a, and alpha beta gamma is negative d by a. So by the given condition, it is given that alpha plus beta plus gamma is 3. So we have negative b by a is equal to 3. Similarly, alpha beta plus beta gamma plus alpha gamma is 1, and alpha beta gamma is negative 1 by 3. So we have three equations, that is negative b by a is equal to 3, c by a is equal to 1, and negative d by a is equal to negative 1 by 3. So from these three equations, you have to get the values of a, b, and c. And to get the values of a, b, and c, see, all the three equations in the left side, denominator is the same, a. So right side also should have the same denominator here. That means you have to make the rational numbers alike or like. So the rational number in the denominator of the first one is 3 by 1, 1 by 1, and negative 1 by 3. So LCM of 1, 1, and 3 is 3. So make the denominator of each equation on the right side as 3. So rewriting it as negative b by a is equal to 3, that is 9 by 3. C by a is equal to 1, that is 3 by 3, and negative d by a is negative 1 by 3. Now we can go for equating the values of a, b, and c. So we have a is equal to 3, b is equal to negative b is equal to 9, so b is equal to negative 9, c is equal to 3, and negative d is equal to negative 1, so that d is equal to 1. Therefore the polynomial is 3x cube minus 9x square plus 3x plus 1. So using these different examples that you have solved here, so do the remaining questions in that exercise 2.2. Okay, thank you.